we're going to look at some of the formulas for our area, for our circles, triangles, squares, and all kinds of other figures. And so we're going to put together a video for that. I'm doing a little guest appearance today, so you're welcome. Get excited. The first figure we're going to look at is a circle. Remember, we've just got done looking at circles. The key to the circle with your formulas is you got to know the radius. If you have the diameter, that's fine, but you've got to have the radius. Remember, the radius is half the diameter, and there's your radius. The formula for the area of a circle is pi times the radius squared. Pi is a symbol that we will use a lot when dealing with circles with area and circumference. It normally represents just the number 3.14, but a lot of the times we're just going to ask you to leave it in terms of pi. You can't measure pi, it goes out way too far, but for what we're going to use it for, we will probably leave it in the answer, but we also could just tell you to let pi represent 3.14. The formula for the circumference is 2 pi r, 2 times the radius times pi. Knowing that 2 times the radius really is the same thing as the diameter, so it could be pi times the diameter. Both of those will be fine. Example of this looks like if we give you the radius is 3, to find the area, you just plug 3 in for radius. It's pi times 3 squared, or 9 pi. Again, we're going to leave this in terms of pi, leaving pi in the answer. For the circumference, it would be 2 times pi times the radius, and the radius is 3 in this case, so the answer would be 6 pi. That's the basic understanding of how to find the area and the circumference when we're dealing with a circle. We can do different things, and we'll show you some of that in class. But as far as just the general usage of the formula and the pieces of the formula, that's what we've got. Looking at rectangles and squares. Rectangles and squares are really done the same way. Rectangles and squares have 4 sides, 4 right angles. Only difference is the length of the sides. The good part about it is the area of both of them can be found by multiplying the base times the height. You're going to see a pattern here, but you need to understand that the base and the height will always be perpendicular to each other. Okay, the base and the height will always be perpendicular to each other, and in this case, the base and the height, it really doesn't matter which one's the base, which one's the height. You're going to multiply them by each other, and since multiplication is a commutative property, it really doesn't matter the order in which you put them in. The square has the same thing. The square has a base and a height. There's a little bit of an alternative for the square. I'll show you that here right now. The square could also be side squared, because all 4 sides of a square are the same. So the base and the height will have the same length. Look at this example. Here's a square with a side 3. If we're going to use the base times the height formula, all sides are 3, so it would be 3 times 3, which is 9. If we're going to use the side squared formula, the length of the side is 3. Well, 3 squared is 9. It does not matter which one you use. Sometimes when we give you a square, we're only going to give you one of the side lengths. So to look for a base and the height may confuse you for some reason, but it shouldn't, because we know that the sides of a square are the same length, and so we could use either formula. But again, for a rectangle, square, area equals the base times the height, and it's just a pretty easy multiplication problem after that. This is an irregular polygon. This one's harder because you don't have a specific formula, because you don't have a specific form. This has a bunch of different forms, and when you have a problem like this, which you will have, it's pretty simple for the fact that all you have to do is divide it into figures we understand, whether they're rectangles, squares, we could have triangles and stuff like that, but you divide it into a figure that we understand. We have a rectangle on the bottom that has the base of 8 and a height of 2. So the area of that bottom figure is 16. Now, the problem is, for the top rectangle, we don't know the height or the base, whichever one you want to call it. I know that both of those sides are 3, which means that that middle section has to be 2, because we have that's 3, that's 3, that's 2. They all 3 have to add up to equal 8, because they're the same length. So if that's 2, that means that top is 2. So now I have a rectangle with a base and height of 2 and 4. So the area of that top section is 8. The bottom section is 16, which means the whole thing is going to be 24. For a triangle, the formula for a triangle, area equals 1/2 times the base times the height. Again, I said this a minute ago, the base and the height have to be perpendicular. That is the easiest way to understand the formula, is you know that the base and height have to be perpendicular. We're going to give you some triangles eventually where that becomes a little bit confusing, but for the understanding of it, let's look here. The base and the height will be perpendicular. Doesn't matter which one it is. If we rotate the triangle over, the base and the height will still be perpendicular to each other, and that's not that big of a deal. If the base is 4, the height is 8, I get the formula 1/2 times 4 times 8, which is 16. We've got a parallelogram here. And parallelogram's formula for area is base times height as well. I'll show you a twist to this in a minute, but understanding the base will be on the bottom side. The height will not be the slanted height over there. Remembering that base and height have to be perpendicular. There is going to be times where we'll give you the height. We'll just give you the base, we'll give you the height, you multiply base times height. In a second I'll show you a figure with a trapezoid where you actually have to find the height. You will be doing that on this. You need to make sure that you understand 45, 45, 90, and 30, 60, 90, because we will use that to find the height. This is a rhombus. Rhombuses are parallelograms, but they also have congruent sides. All right. The easy formula is, again, it's a parallelogram, and so it's base times height. But again, base and height have to be perpendicular. But the area of a rhombus could also be 1/2 times the diagonal 1 times diagonal 2. Sometimes we'll give you diagonals and we won't give you a base or a height. If I give you that portion of the diagonal is 3, that portion of the diagonal is 4, I remember the rules about diagonals, rhombuses, which say that the diagonals bisect each other, which means that the other section is 3 and the other section is 4. So I get 1/2 times 6 times 8, because that whole diagonal is 8, this whole diagonal is 6, so I get 24. This is a trapezoid. For a trapezoid, the formula for that is area equals 1/2 times the height times the sum of the bases. Alright, 1/2 times the height times the sum of the bases. The bases will always be parallel to each other. They will be on the top and bottom. Alright, they will be parallel to each other, and the height, again, will be perpendicular. When you have an easy picture like this, you're going to take 1/2 times the height, which is 4, times the sum of the bases. So 1/2 times 4 times 9, your area equals 18. That's a pretty easy one. That's when we give you the height, we give you the bases, and you just put the formula in. Remember, height and base have to be perpendicular. This is one of the ones, like I was talking about with the parallelogram, where occasionally you're going to have to find the height. The parallelogram and the trapezoid, and occasionally with the triangle, we don't give you the height sometimes. So if I give you that corner angle is 45 degrees, I give you that slanted area is 4, the slanted side is 4 square root of 2, the base 1 is 5, and the base 2 is 10. You've got to find the height. Now we've got to go back to our rules on 45, 45, 90 triangles. I have congruent angles, which means that is the hypotenuse. To go from the hypotenuse to the leg, you divide by the square root of 2, which means that the height is 4. So my formula now turns into 1/2 times the height, which is 4, times the sum of the bases. 1/2 times 4 times 15, 1/2 times 60. The area equals 30. All of these figures can get harder depending on what piece of information is given to you, but for the most part you need to understand the formulas, and then you need to understand that the height and the base will always be perpendicular to each other. Hope that makes sense. Thanks.